Hello, welcome to another video on creating matrix in LATEX. There are different types of typesetting matrices. Different kinds of matrices. First kind is this type of matrix. Another type. Mainly the difference in matrices is due to the bracket that we use to enclose the rows and columns. You can see this kind of open bracket is used here. In this case, you can see closed brackets are used. Now a third type of matrix, here we know that it stands for determinant. In this type of matrix we use vertical lines to enclose the rows and columns. How can we produce this kind of different type of matrices? We can see them one by one. Okay. See, for producing this output, you can see the part of the source code here, given here. See, some mathematicians write, etc. You can see, and this is but ordinary matter up to this word, up to the word in. There, the matrix starts. There we have a matrix. And that matrix actually it is in a mathematics environment. So we have to create that mathematics environment. After creating that mathematics environment, you can type the matrix. You can type the command for the matrix. But you can see this mathematics environment is a part of the that line that we have already started here. A line we have started here, and so you can see this comes as a part of that line. In other words, it is not separated from the from that paragraph. So you can use single dollar. You have to use a single dollar symbol to create the mathematics environment. No other type of commands should be used. So single dollar command can be used. So you can see that here after in the single dollar is returned. So that will be closed. That environment will be closed by typing another dollar, single dollar. In between the two single dollar symbols, you can see the commands for creating the matrix. And that I can read that /begin p matrix. This kind of matrix is produced by the command matrix, p matrix. So /begin p matrix that ends with /end p matrix, and the elements in that matrix can be entered one by one between these two commands. You can see as we enter the matrix, you have the first row. The first element you can see the first element, the first row. So row wise you have to enter these elements. We have to enter, but to specify, to differentiate the columns, you can use and character or and symbol you can use. So as we enter the first row, we can see the first element. So that element is written is typed A. That element A is typed. After that we have B in another column, in a different column. So you have to specify that B, the number, the letter B, that must come in the next column. So for that can be done by using the AND character. So AND then B, and after typing B, you are now standing at the at the end of that row. So you have to specify that you have to tell the system that you are at the end of, you are standing at the end of the row, and that can be done by using two backslashes. What next? Then you have the second, you can come to the second row, and then and you can type C. In the second row, first element is C, and after that next element is D. That must be in the next column. So and can be used. C and D can be typed in the next row. So by doing this, you have completed the entries in the matrix. So we are now done, and that matrix, the typesetting of that matrix or the source code of that matrix is now complete. Next we come to next we have to continue that in the same line. In the same line, you have to continue by typing while others prefer prefer square. While others prefer square brackets, as in another matrix which is given here in square brackets. So up to typing up to this in, you have to begin another mathematics environment. You have to begin another mathematics environment, and that mathematics environment, of course, you can begin by putting the single dollar. By putting single dollar, that can be closed by putting another single dollar. But between that, or inside that mathematics environment, you have a matrix in square brackets. So the entries can be, or the matrix part can be completely entered exactly as in the previous case. The way we have explained the way we have done that, it can be repeated here, but only with one difference. That difference actually differentiates the matrix, the new matrix, from the previous matrix. That difference is that we use B matrix instead of P matrix in this case. So we begin the statement or the command /begin B matrix. Remember that B matrix can create the bracket in the square bracket in that matrix. Okay, then B matrix. After that, since the entries in the matrix are same, you can if you want, you can copy and paste it from the previous entries from the previous matrix. You can copy that matter, and after that you can complete that entry in that matrix by typing /end B matrix command. Okay, by that we have finished that entry of the matter, or the typing of the matter to produce the output. Okay, and then another different type of matrix you can see here. In that matrix you have square brackets used. Okay, so in order to type this, that also we will explain before we begin our demonstration, or by our demonstration session. Before starting the demonstration session, we analyze the source code to generate. We shall analyze the source code to generate another output, which is given here in this box. See, in this box, the determinant of we have the matter appear displayed. The determinant of the matrix A B C D is defined by A B C D equals AD minus BC. Okay, let's come to the source code portion. First, you have to type the determinant without any without any special commands. Ordinary, it's an ordinary matter, so you can type as it appears there. You can type it, but after that you come to this point. It here you can see that there a mathematics environment begins. So and also this environment is a part of that line or the paragraph, so you can use a single dollar. This single dollar is then typed. You can put that single dollar here also, just after the word determinant, but that that doesn't make any difference actually. But in order to give the source code a good appearance, and also to make it very easily understandable for others, we are using this structured style actually, and this is a good style of typing the matter. For a new person, a third person, or a second or third person can easily read the source code and understand what is actually written there. But on the other hand, if you are typing it all in one line, that will make a very big confusion, and okay, so that type of practice is avoided. So this is a good practice of typing the source code line by line, and then important point, or the section by section. Complete sections are typed in one block. You can see this is a complete section. A complete section here, dollar starts or mathematical environment starts there, and that environment is closed, or it is closed here, putting another dollar. So you can see that you can treat this portion, this highlighted portion, the selected portion, as one complete section. After that you have these three words as a complete section, and there after typing by, you can see another complete section here, a meaningful section of the source code here. So this way you have to divide the source code, the entire source code, and you should try to understand each part of the source code separately. And also you can see that if you are trying to separately typeset these complete portions, and one by one if you are taking the output, you can see very easily, you can understand the meaning of that portion, and the way the system, the LaTeX system generates the output, you can easily understand. Okay, now coming back to our discussion on that matrix, this is here we begin a mathematical environment by putting the dollar symbol, and we start the matrix by typing /begin v matrix. You can see the difference and this is a different matrix command compared to the B matrix and what we can say the P matrix. The two other commands are B matrix and P matrix. So this B matrix of course produces this vertical line, and that is the difference. Okay, now /begin V matrix, then we have A and B, new line character, double backslash, then C and D. Coming to the end of, now we come to the end of that the second row, and so we want to close the matrix by typing /end V matrix, and then we close that mathematics environment. After that you type is defined by, okay, then you have you can see a mathematical environment, another mathematical environment, but this mathematics environment doesn't come as the part of the continuation of the line that you can see, which ends with by. This is the line is defined by, ends with the word by clearly it is very clear that the new mathematics environment doesn't come the part of that line. So I mean it's a separate it is separately displayed here, and also it is centralized. This kind of mathematics environment can be generated by using different commands, and there are various commands to generate this kind of mathematics environment, but most commonly we are using equation / begin equation command. Begin equation and end equation command can be used. But you can also see that there is no tag or there is no number associated with this mathematics expression or this equation. So you have definitely you have to put the star symbol after the equation. Okay, in order to tell the system that will tell the system that will inform the system that no tagging or no numbering of the equation need be done. So we can begin that mathematics environment here by / begin equation star. Then inside that mathematics environment we have that matrix. So we begin the matrix again. Next we begin that matrix. So first we start the mathematics environment. After that we begin the matrix environment. Okay, that matrix environment is started with the command / begin v matrix, and then you can enter the elements a and b by 2 backslashes. Then next row elements are c and d, and that matrix environment is completed by typing / and v matrix. Of course, now okay, now by typing that / and v matrix, you are at this point. Now you have to be very clear about the position you are standing at each stage. At each level, at each step of typing the source code in LaTeX. Then you should be very well aware of the position you are where you are, your current position. You should be aware of your current position. Okay, now when you finish this the / and v matrix, now you are standing here. So next what you can see is a symbol, is the equal symbol. So you have to put that next equal symbol. After typing / and v matrix, you have to put that equal symbol. Next, immediately you have to type equal symbol. After that, when you type equal symbol, you have crossed this position and you are now standing here. So when you are there, you can see AD minus BC, that two terms are there, AD minus BC, and these quantities these letters you have to type next. So that you can see that is typed AD minus BC as ordinary typing. Using ordinary typing, using the keyboard, you can type that. Okay, after typing B into C is not required. You can just type BC, and here A into D into is not into is understood there, and then there is no separate symbol. We usually don't use any other symbol, any into symbol for multiplication. So when you type BC, you are standing here, and therefore you are standing here means you have finished that entire mathematics environment, the typing in the entire mathematics environment. So you are now in a position to close that mathematics environment. So we type / end equation star / end equation star. That was what was the command that we used to open that mathematics environment. That command is / begin equation star. So we use / end equation star. So by typing that, you have completed all the source code. You have completed all the steps to create the matter displayed in this box. Now I am going to demonstrate it by using the software LATEX, LATEX software. Okay, for that now I am going to use Text Center, the software Text Center. You can see here in this Text Center, it is open. Technic Center, TXNIC in here. Technic Center is the it's read as a Technic Center, and it's a software that in which we can create LATEX files, and we can run it, or we can compile it to view output either in PDF or in some other suitable format, like the formats like DVA and PS PostScript, and different types of formats are there. Now here we have a selected LATEX to PDF for this conversion. Now you can see here here a program is there, completely typed. We will come to this program after some time. Now I am going to create a new file. Actually, I am going to create a new file. For that, some basic ideas are required which are used here. I don't want to repeat it I don't want to repeated typing of the material, so I will copy it, and then I will create a new file. So I have created I have opened a new document in which the things I have copied, so I have selected, I have copied, will be now pasted here. It's now pasted. Now I am going to you can see here the header part contains the commands /document class A4 paper comma 12 point article, and after that use package. I think that well about the uses of packages, suitable packages. Packages are help the LATEX system to perform some advanced operations, some advanced computation. So computer by computation means I mean this typesetting actually. So to make it to perform the LATEX basic LATEX system to do advanced functions actually. Many advanced functions can be performed using a suitable for performing a particular function, and there will be some suitable package. That kind of packages are included here. You can see. So use package using the commands use package. You can include the packages here. GEOMETRY geometry is the package included, and another package included is PyFont package. These are all very important actually, and these are the two packages used here. But to perform some other advanced functions, you may require other packages. See, and these are the first line, and then use package type commands are there. After that, you can see the main command, the begin /begin document command is there, and okay, immediately after you can see, after that you can see the matter, actual matter which are to be generated are entered here using various commands. So since we are not going to say anything about this matter, so I will remove that, and thereby I have created a basic document I have created a basic LATEX source code I have created, you can see, and this is the basic requirement for a LATEX source code, basic source code. You have you can see here the first line itself, you can, that's very important, and then use package statements are there, and just below that, and we have then another important the starting of the document command, begin document document, and the end of the document command /end document. Between this I am going to typeset the matter that we were discussing about. We were discussing about that matrices, different types of matrices. So I will one by one I will copy, and actually I want to type it, but not avoid because we don't have much time to spend. So to save time, I copy it, each complete module I will copy. So that's the that's an important thing actually. If you want to if you want to get an output step by step, you have to finish typing of complete sections, or complete you have to complete the typing of a complete part of the source code. So this is a complete part of a meaningful and complete part of source code, and that I am copying into the field, okay, into the program. After that, I will take the output. I am going to take the output because I want to know whether it is properly functioning, whether any error has occurred, or whether the typing is okay, whether it is producing an output. That's very important. So I will go to this build command, and for different softwares will have and these functionalities in different presented there in different way. So there is no standard way of generating this output, but there will be some way to generate the output. So that depends actually on the software, the supporting software of LATEX. Okay, so that's also another point that you should note. Now here we have that build in the build command. You have in the build menu you have these commands. Here we choose this is the actual build, and view is the command, and that we want to apply. But you need to save. It will then immediately ask you have to you haven't saved. It will remind you that it will inform you that you haven't saved it with a suitable name. So first thing you have to that you have to do before you go for viewing its output is you have to save the file properly in a proper location. So here this is a location where many LATEX source codes are saved. So I will because automatically this location is actually selected by that system. But you can if you want, actually if you are interested, you can change this location. There is no problem. By clicking here you can browse and you can select some location which is in the system, in the computer, some folder, some subfolder. That way you can select it, the location. But I would like to continue with this location. I am satisfied with this. I will continue with this here. But I will choose a name, a suitable name here, since this is about the matrices. So I am going to give the name matrices. Already there is one file named matrices, MATRICS matrices there. So I want to make it matrices 1. That number will be suitable, matrices 1, and then I save it. Okay, after that, after saving that, we'll again select this this build command, and there I okay, yeah, that has started its function. Its function it has started. Okay, that you can see. Okay, yeah, you can see that output it has generated, but it is not properly coming, and that the required output it has not generated. I think this is due to some lack of packages yeah, there. It is due to the unavailability of packages, or due to the lack of supporting package there in that program, because in other words we can say that that package, the required package, is not mentioned there. So that's why I think so. I will try with the package that may be the supporting package, some suitable package. I will find, and I have to include that that package here. Then we will try again. So I'm going to close it, and okay, once again let's try to build and see whether it is, yeah, it's showing the same output. Okay, so let's here's only geometry and pyfont, and these are the packages included. So yeah, of course we need more packages. Okay, I copy it, then AMS math, AMS MATH. It's an important package, and AMS SIMB symbol, AMS symbol. Okay, let's take again the output. Yeah, that was the problem. Now you can see that that matrix here. Now it is clear why. You cannot understand what was the reason that output was not properly there displayed. Now now you can see that the output is there as we actually required it. Actually we were trying to create which output, and this was the output we were trying to create. Now this, okay, after this as in was there, it was displayed here. Since this it is because you can see a difference here. Actually that this line was actually more lengthy compared to the output that we generate here, that we have obtained here. So that is due to that field, that the default measurements given for the or selected for the for this page, or default measurements given for the margins of this page actually, and for that that also you can change, but at this moment we don't try to do that. So we are satisfied with this this kind of this field of output. So we don't want, because it is very it's an advanced topic actually, the changing the field of the output, or the changing the margin of the page of display. So that's an advanced area, so we don't want to discuss about that. We will continue with this, so due to this limitation on the available area of display, and this will be the output, the remaining output will also be affected. Anyway, we are getting that output. Okay, now we then come back. We are going to continue with the remaining portion, and I will copy the entire thing and paste it there just below that already typed my material. Then again I will continue that building procedure. Okay, now you can see yeah, the remaining portion we have in the display. The remaining part has been displayed here. Okay, next next I will continue typing. I will continue to demonstrate the remaining the third type of matrix, how to generate the third type of matrix by copying the remaining part here. Up to this portion is meaningful, is a complete portion, so that part is copied and will be pasted in the file, and then we will take the output. What's the problem? That it shows it doesn't show any output. Okay, yeah, output is there. It has generated this output, and this is the portion, the determinant. Okay, then this kind of matrix, the third type of matrix, you can see. Okay, we can we want to complete that by copying the rest of the commands, and we will take the output finally. Okay, then end equation. Okay, I'll take the output again. Okay, if it does not come, that output if it does not come, then you have to take it. You have to yourself, you have to go to that, and this is the output here. It's not PDF. Actually, it is called GS view. Another viewer. Okay, this is not a PDF viewer. This software is called the GS view. Okay, and so you can see some difference when you view the output using PDF viewer. You can view it in a different style. That difference, that appearance is a little different from what you can see here. Okay, and then the determinant, this one A B C D is defined by okay, it is defined by that A B C D, determinant of A B C D equal to AD minus BC. Okay, and that's the end of that discussion on typesetting different types of matrices. Thank you.